Well, this is a subject that not many people like, and understandably so, but maybe we can show you something that will make this a little bit easier. So we're going to take this idea of estimation, and I wrote the same example with the same dividend, but different divisors to show you why estimation can be useful. So what I like to do is split these dividends up into zones by number. So there's a ones, tens, and hundred digit, but when we do division, we start on the left side with the biggest place value, which in this case is a 4 in the hundreds place. So the first thing you got to ask yourself is, can 23 go into 4? No. So we're going to add the second number in. So we're thinking of 48 now. We can't just assume that the 4 is, we're not using it anymore. We can't just get rid of it. If you want, you can even write a 0 up here to remind you that you said that 23 can't go into 4. So now that we think of 23 into 48, do you see how this has the same amount of digits as this? So if that is the case, then I use the first digit from here to estimate, and let's use a different color, red, and I'm only going to use the first digit in the divisor as well. Remember, we split this up here, so we're thinking of 48 and not 482. So we're only thinking of 2 into 4, or 4 divided by 2, and hopefully you can easily say, okay, that answer is 2. 2 goes into 4 twice. So we're always going to check here, and I like to write right underneath the divisor that multiplication fact, the quotient number that I got, 23 times 2, which is 46. And to check it, we look at 46 and say, well, it's really close to 48, but not bigger than 48, so that's a great guess. We're going to subtract to get a remainder, and as always, we're going to check to make sure our remainder is smaller than our divisor of 23. If it's the same as our divisor or bigger than our divisor, speaking about the remainder, then we know our guess here is too small. We need to go bigger. But since 2 is definitely smaller than 23, we are good, and we can go down, bring down the 2, and now we've got to divide 22 by 23, which we should know since 23 is bigger than 22, we cannot divide 23 into 22, so we write a big fat 0. Our remainder is just the number that's left over. Remember to check, have we used all the numbers inside the division box? Okay, so let's skip over to this example. On the right, same divisor, different divisor, same dividend. So I'm going to do the same thing where I'm going to split this up because we know that 28 is too big for 4. So we're going to divide it into 48. We're going to include that whole number now, or these 2 digits. And because this is a 2-digit number divided by a 2-digit number, we only need to think of the first number for estimation. Now, look at 28 and look at 23. If I were going to round down or round up for each of these numbers, I would have rounded down, sorry, I don't know what that was, I would have rounded down to 20 for 23, but for 28, I want to round up to 30. And the reason why that makes a big difference is because you can see here, if we're only using the first digit here and the first digit here to estimate, and we're going to do the same thing here, use the first digit and the first digit here, 4, we're going to think, okay, how many times does 3 go into 4? Well, it only goes in once, right? As opposed to the 2 that we used here. So let's check it. 28 times 1 obviously is 28. And that's close to 48, but not bigger than it. So we can check to see if 28 is the right answer by subtracting and checking our remainder, right? If our remainder is smaller than 28, not 30, that was just the estimate, but 28, then we're good. And 20 is definitely smaller than 28, so we can bring down our next number of 2. So here we go. Now we have an interesting situation where instead of just a 2-digit number divided by a 2-digit number, now we have a 3-digit number divided by a 3-digit number. So we're kind of going to use the same process, same estimate number of 3 from 30 because we rounded up from 28. But now we're going to see, can 3 go into 2? No, it's too big, right? So now we're going to do 3 into 20. So to estimate that, 3 times 7 is 21, so we know a multiple of 7 is too big. So let's try 28 times 6. So we use the 30 to estimate and get a quotient value of 6 here, but we have to check it with our original divisor as always. We never use the estimated answer to check. So 6 times 8 here is 48, carry the 4. 2 times 6 is 12, plus 4 is 168. So of course, we're going to go ahead and check and see, is 168 the right answer? Because we need to see what our remainder is. So 12, when we borrow from a 0, it becomes a 9, remember, and it's a double borrow. You automatically take 1 away from the next number. So 12 minus 8 is 4. 9 minus 6 is 3, and we can already see our remainder is too big. It is 34, and our divisor here is 28. So I'm going to erase this because this is not right. As best as I can and make it as clean as I can. Okay, so we said that 6 was too big, correct? We used 6 down here, and we just saw that 6 is too big by checking it. So what do we have to do? We have to go down. And the best thing to do, since we know we're really close, is go down by 1 multiple. So let's try. Oh, sorry, we said 6 was too small because our remainder is too big. So that means we need to go up. So that's a common mistake to make. I even said it trying to explain it, so I'm not perfect. You can see. Just ask my mom. 28 times 7, let's check it. 56 is that answer. We carry the 5. 2 times 7 is 14, plus the carryover is 19, so it's 196. And, sorry, I erased the remainder. So we're going into 202. We brought down the 2. So 196 is our multiple. Sorry if this is a little cluttered. I'm using a makeshift, kind of cobbled together, very questionable as far as functionality goes, set up for doing these videos. But we're going to subtract. We borrow, like I said. When you borrow from a 0, it's a double borrow. And that becomes a 9, so 12 minus 6 is 6. And look, our remainder is 0, 6. That is definitely smaller. So we know that answer of 7 that we used is a good one here. And we've used all the numbers, so the remainder is 6. So clearly you can see this is not a perfect science. What it's meant to do is just kind of speed up the process. Usually what I found is if you use this estimation method, even when you get one wrong here, like we used 6, it was too small, you're usually within one of the right answers. So you just need to know whether to go up or down. How do you know that again? If your remainder is bigger than what you divided by, this multiple here needs to get bigger. That's why we went from 6 to 7. I misspoke, but I want to be very clear. If the remainder is bigger than your divisor, you've chosen a multiple that's too small. If you multiply and the number here is actually bigger than the number you're trying to divide into, then you know your multiple is too big. So if we use 7 and let's say we got like 250 dividing into 202, well then we know we need to go down. So using that idea can help speed up things, but once again, this is a process you're going to use when you've already mastered single-digit division, when you understand the steps right here of estimating, dividing, multiplying, subtracting, and bringing down, all while checking in between these steps to make sure you have the right remainder or right multiple. And then you have to repeat everything every time you bring down a number. So there's a lot involved. Once you understand how to break up a dividend, and then you learn these steps, then I would say it's a good time to throw in this idea of estimation. Students who have good number sense are going to benefit from this a lot more than students that don't. So that's why it's so important to develop that idea of mental math and number sense from a young age, even from preschool or kindergarten where they're just learning how to count. So hopefully you can take these ideas and put them to use. Of course, it's going to take a lot of practice. This is a very mechanical process. There's a lot of calculations involved, which means there are a lot of areas to make mistakes. So what I would say is make sure when you check over your work or your students' work, point out the small mistakes that they made. Let the student or yourself understand why they got it wrong and how to fix it. And then I would say keep practicing. That's the idea here. A concept like this or a process like this where there's so many steps is just going to take a lot of time to master. So get to work. Don't get frustrated. If you do, put it aside, come back to it the next day. Long division isn't going anywhere. So as you can see, guys, long division, is it an exact science? Absolutely not. But that's why it's so important to be really good at the estimation process, and why I focused on structuring it a certain way with the dotted lines and the zones that I created within the dividends. I think it's just really important for students to have something to react to and steps to turn to immediately, steps that you don't have to question, do I do this first or not? So there's a lot of repetition that's necessary to really get those steps ingrained. But I think that's an important idea in such a complex concept or mechanical mathematical problem like long division, where there's so many different things involved. It just means there's so many more different areas to make mistakes. So what I would say is really get accustomed to dividing larger numbers, having larger dividends, and also larger divisors. How often is your student in the third, fourth, fifth, sixth, whatever grade, even all the way through college, how many times are they going to be required to divide a 5-digit number by a 3 or 4-digit number? Probably not often, but the ability to do it, I think, is what's important. And it's one of those things where you learn once in life, and even if you never use it that much again because you can use calculators and things like this, maybe it's not the most important concept in that sense, but the ability to put together addition, subtraction, multiplication, and division in different orders, in different concepts, or on one single problem, I think is incredibly important to master, because you're going to do that later on. That's what algebra is. That's what pre-algebra is learning to put things together. So I hope you can take these ideas and put them into practice. Remember, this is not an exact science, so it's about just kind of building confidence in your ability to guess and check really well and making good guesses. Most students will find it much more bearable if they don't have to guess 5 or 6 times just to get one of the quotient answers that are necessary to solve the problem. So I hope you can take these ideas and thoughts and put them into practice. I wish you the best of luck, and as always, I am wishing you well.